All right, we are back to 5. We're going to learn about something called completing the square. So completing the square means that you have a perfect square. So for example, let's say you had 25 equals x squared plus 14x plus 49. Okay, if we had to factor that, right? The first thing we would do, well, let's leave 25 over here. We had to factor the right hand side of this. Hopefully you guys can see that if I'm thinking a times b has to be 49, and then that means a plus b has to equal 14. There's no negatives here. I end up with, I'm seeing that I can use 7 times 7 and 7 plus 7, right? So that means that what I have on this right hand side is x plus 7 times x plus 7. And hopefully you can do that quickly in your head, see that that gives you that right hand side, which then I can rewrite as this. Okay, so this is a perfect square. This trinomial, right, or this quadratic equation expression here, x squared plus 14x plus 49, is a perfect square because it is x plus 7, that expression squared. And you could then solve for x if you needed to, right? So what would I do first? Well, first I need to get rid of this squared, so I'm going to take the square root of both sides. So then I would end up with, so now here's where we need to remember this. The square root of 25 is actually positive and negative 5, right? Because negative 5 times negative 5 gives me 25, and so does the positive times the positive. And then over here, if I take the square root of that, it's just x plus 7. Okay, so now let's set this up as negative 5 equals x plus 7, and then 5 equals x plus 7. And now I can solve for x. There's two solutions. Take away 7, so minus 12 equals x, minus 7, minus 2 equals x. So those are the two solutions to that equation that included a perfect square. So sometimes what happens, the reason we do this, is there will be situations. So let me give you an example. Let's say we have this. Okay, if you had to factor that, let's see, what could we do? We know that a times b has to be 3, but then a plus b has to be negative 2. So really all we're multiplying that we can get for that is 3 times 1 and negative 3 times negative 1. That's the only way we can get positive 3. But no matter what I do with those, I cannot add those to get negative 2. So this thing cannot be factored. So if you're stuck with that, stuck at that point, but you need to factor it, you can do this process that's called completing the square. Make it a perfect square. So if you need to make it a perfect square, you need to look at the b term. Make a different color. So here's the b term. So what you're going to do first is you're going to take b. We need to find this. This is the key to making this a perfect square. Why? Because if we make the third term in this quadratic b over 2 squared, then that means when I'm multiplying them and then adding them, I'm really going to be able to just repeat the same number, right? So if I take b over 2 here, it would be 14 divided by 2, that's 7, and 7 squared is 49. So that makes this a perfect square, this pattern. So let's figure out what that would be here. So our b is negative 2. We need to divide that by 2 and square it. So that becomes negative 1 squared, which is just 1. Okay, so we need to use this thing to make this a perfect square. So here's what happens. I'm going to rewrite this. I'm going to leave a space here because I want to make this a perfect square, and then I'm just going to add the 3 over here. Okay, so I'm leaving this space, and I need to attach this 1 to these first two terms to make it a perfect square, right? Because if I have 1 minus 2 and then plus 1, it's going to be a perfect square. So I need to add that 1. So I'm just going to go over here. I'm going to just say plus 1, and I'm going to write it on the diagonal because I know then that's there. But once I add this 1 to the equation, it is no longer the same equation. It's only the same if I also subtract 1, because then I've essentially added 0, adding 1, subtracting 1. So I'm going to add 1 to this part, so you can imagine like I've broken it up into 2 parts. I've added 1 there to that part of the equation, and I've subtracted 1. Well, actually what I would do, No, yeah, I'll leave it like that. I've subtracted 1 from that part. Okay, so now let's rewrite this. So now I have 0 equals x squared minus 2x plus 1. And then over here, I have plus 3 minus 1, so that's just plus 2. Okay? This is still in our parentheses if you want to think about it that way. Now I can factor this, because guess what this is? X squared minus 2x plus 1 is a perfect square. It's a perfect square of x minus 1, right? Because x times x is x squared, then it's minus x, which gives me 2x, and negative 1 times negative 1 gives me 1. So it is a perfect square. I have completed this square, but I still have the plus 2 hanging on the end here. All right, and hopefully this looks familiar. That is the vertex form, right, of for quadratic equations. So right there I could pull the vertex out, right? But this, let's solve it. So really the directions here was solve using factoring. So we factored, now we can solve it. So let's just do that on the side. So now if I take the 2 over, I have negative 2 equals x minus 1 squared. Now I need to get rid of this squared, so I'm going to take the square root of each side. So I have the square root of negative 2 equals x minus 1. Okay. And then I'm going to add 1 over here. So the square root of negative 2 plus 1 equals x. Okay, but I can simplify this more because I can get rid of this square root of negative 2. We know that the square root of negative 2 is equal to the square root of negative 1 times 2. And that's still plus 1 equals x. And then I know that the square root of negative 1 is I, right, from our last lesson. So really what we're left with is x equals 1. And then let's take the I out, and we still have a 2 in here, right? But here's the thing. Because it's the square root and it's I, it's going to be plus or minus, just like it was plus or minus up here, right, when we took the square root of 25. So there are 2 possible solutions to this, and you'll usually see it written like this: x equals 1 plus or minus I times the square root of 2. You'll see it in that complex number form first, right? A plus bi. So whenever, really, you need to just remember when you're taking the square root of a number, it's going to be the positive and the negative. So let's try another one.